The topic of this video is mixtures, which are otherwise known as impure substances. Now, chemistry is the study of matter and change, and as this slide shows, we can break a lot of things down into a dichotomous world, either being one thing or the other. Matter can be broken down into two types: pure substances and impure substances. A pure substance is defined as something that has unvarying composition. You can have 100% of it. Example, I can put a pile of pure gold in front of you. I can put a pile of a substance that only contains sugar molecules, so it's 100% sugar. If something can be 100%, then it is a pure substance. Impure substances, on the other hand, have a varying composition, or, in other words, the percentage of the components can vary. Think of a cup of salt water. I start with pure water, only water molecules. I then dissolve a teaspoon of table salt into it. I can make it saltier by adding another teaspoon of salt and stirring it up. So you can look at it this way. I can't have gold that is golder than gold. I can have salt water that is saltier or less salty. So if I can use a comparative methodology, such as adding ER or EST or more or less, then you have a mixture. Pure substances consist of elements and compounds, and we'll deal with those in the next video. Impure substances are sometimes called mixtures, and that's what the remainder of this video is going to deal with. So let's define what a mixture is. A mixture is a combination of two or more compounds such that the compounds do not interact chemically. Each component of the combination of the mixture will keep its own physical properties. And because each component retains its own unique set of physical properties, mixtures can be separated utilizing differences in the physical properties. We'll discuss that more a little bit later. So now we're back to a dichotomy. There are two types of mixtures: homogeneous and heterogeneous. And if you go back to your roots, you know that homo means the same and hetero means different. In a homogeneous or homogeneous mixture, every sample of the mixture is the same. It has the same percentage of each component in every single sample. Examples that you may know of homogeneous mixtures: salt water, air. If you walk around the school, the composition of the air is the same everywhere you go. 79% nitrogen, 21% oxygen, 1% everything else. Coffee is a homogeneous mixture. Chrome is a solid, but it's still a mixture, and it is also a homogeneous mixture. Every sample of chrome that you get is going to be the same as every other from that lot. White gold in jewelry is a mixture of gold and platinum, and once you mix it all up, it is a homogeneous mixture, but you can vary the percentage of gold and platinum. Well, if a homogeneous solution, every sample is the same, then in a dichotomous world, a heterogeneous would be the opposite, and it is. Each sample of a heterogeneous solution is different. Examples: a double anchovy pizza. Every bite you take will have a different amount of crust to cheese ratio, to tomato sauce ratio, to anchovy ratio. Chicken noodle soup. Every spoon you take will have a different amount of noodles, broth, and chicken. Chocolate chip ice cream. Not every spoonful has the same number of chocolate chips. Oatmeal raisin cookies. One bite may have 3 raisins, the next bite may have 5. And if you have a mixture, it can be separated, and it can be separated by physical means, by using the physical properties, not the chemical properties. When you separate a mixture, you should get back the original components. Now, some of the methods that can be used, and these are not all of them, include filtration, which separates a solid from a liquid, and this actually can only be used in a heterogeneous solution. An example is when you make pasta, you boil the pasta in water. That is a heterogeneous solution. You put it through a colander, the water drains out, and you're left with just the solid pasta. Some people like to refer to this as straining, but the scientific term is filtration. Distillation uses differences in boiling point to separate materials. This is classically used to separate liquids by utilizing differences in the boiling point, but you can consider evaporation a method of distillation, which is one way of, say, making sea salt, where you take seawater, allow the water to evaporate, and what's left is what's called sea salt. Chromatography, which uses differences in solubility, the ability to be dissolved in a liquid, to allow for separation of the components, and you'll be doing a lab on this later. And centrifugation, utilizing centrifugal force, a machine similar to a tilt-a-whirl, and difference in masses of the components of the mixture to separate out the various components. This cannot be done when something is dissolved, but it can be done in other types of solutions. So it uses centrifugal force and mass. And here's a vial of blood. This is where we classically utilize centrifugation, because we know that red blood cells are solid, plasma is liquid. If you take a tube of blood and put it into a machine called a centrifuge and allow it to spin at 20,000 rotations per minute or so, after a few minutes, all the red blood cells are at the bottom of the tube and the plasma is at the top. And this is what they do in the labs and what they do in the blood bank. So that's a brief description of mixtures. In the next video, we'll talk about pure substances.